Let us start the embedded system lecture. Good evening. It is embedded system PET 3102. The course outcome, students will be able to select the relevant microcontrollers for various industrial applications. Students will be able to use embedded C programming language to maintain the embedded system. Students will be able to interpret the communication standards for embedded systems. Students will be able to develop the basic applications of the embedded system. Students will be able to interpret features of the real-time operating systems. So embedded systems we have seen definition, examples. Embedded system is the controlling system and not basically the computational system. The different parts, hardware, software, and operating system, application software, and operating system. And operating system is basically RTOS, real-time operating system. Then we have seen the various parts in the circuit board, then applications, embedded system application, block diagram we have seen, different applications again listed, types of the embedded system, real-time, standalone, network, mobile, which we have seen, then the subtypes, like real-time, ARM, details of that, standalone, their applications, network, their applications, mobile, their applications, or examples, you can say, not applications, examples. The characteristic also we have seen, small form factor, power components, function, lower cost, like recursive, reactive, real-time performs specific tasks, part of the main system. User interfaces are there, user interfaces for communicating the user from microcontroller and from user to the microcontroller. Keyboard is there, display is also there. Similarly, from one microcontroller to the other microcontroller, one embedded system to the other embedded system. So for that there are protocols one can processors of embedded system. How processors of the embedded system are selection is there, selected, that is also what are the specifications, what are the parameters for selection of the embedded system processor of microcontroller. There are ready-made boards also. We have seen the board like Arduino board, Pi board, banana Pi board, yellow board, many more are. Then embedded system characteristics continues the power consumption, parameter which is also more important characteristic, flexibility, processing power. The operating system has to take care of constraints on memory, size, time, processing power, etc. Accordingly, the operating system is built, is written, is operating, is working, is running, considering all these parameters. The performance of the processor or microcontroller as well as the total system. Then what are the memories, types of the memories, size of the total circuitry, reliability of the circuitry or system. Reliability is the guarantee. Safety, if that circuit burns, it should not be harming other. It should not harm other circuits. If this system burns, it should not disturb or harm other systems. Correctness after testing, the circuit embedded system is verified for its correctness or tested. Okay. Functionally, the system should be checked. This indicates functionality of implemented system is correct or not. Maintainability, it is the most important factor of the system. Maintainability is the most important factor of the system. in which system can be repaired or replaced within the certain time interval. So system is repaired within certain time interval. Certain time interval is important because if the system is deployed, that means used on the production line of the factory, industry, robotic arm, conveyor belt, automatic detection, automation, etc. Then, if the embedded system fails, that system is failing or fails, then within certain time interval it can be repaired or it can be directly replaced with the other board, and the industry production will continue and the replaced board will be further repaired. So this is called maintainability. Maintenance should be there, otherwise there will be large loss of the industry. Okay, isn't it? Industry is working on loss and profit basis. If there is a maintainability, poor maintainability, then it will be the uh, issue of concern. It will be the point of concern. Advantages: easily customizable, low power consumption, low cost, enhance the performance. These are the advantages. Similarly, high development effort and larger time to market. These are the disadvantages. And we have seen the microcontrollers. It is a solitary chip microcomputer fabricated on VLSI. It is a microcomputer. Just we are discussing in the previous lecture OSSS. It is a microcontroller, microcomputer. Same thing we have discussed now. At the end of the open source software hardware 6-7 minutes, the lecture of the today's lecture of the open source hardware software hardware 8th lecture of the open source software hardware. Same we have discussed. What is there? That is, the microcontroller is solitary chip microcomputer. It is the microcomputer on the single chip. It is computer, microcomputer. The compressed computer, because it is having the processor, it is having the memory, it is having the RAM, it is having the ROM, it is having the keyboard interface facility, it is having the display facility. Maybe display may not be like the high resolution TFT or LCD display or LED display of the computer or laptop. Maybe 16 by 2 LCD display will be there, simple LCD display, but there is a display which is the output device which can be connected. Maybe very small keyboard, 4 by 4 matrix keyboard or like that, 16 key matrix, that can be interfaced. But that is the keyboard which we are interfacing. So there may be the USB connection, there will be maybe Ethernet connection, connectivity. There may be some other external memory connection, external memory facility can be uh, used with that. So all these features are nothing but features of the microcomputer. So it is a microcomputer. And basically on single chip, all these processor, memory, ADC, DAC, timer, ports are there. Serial input, serial output. This is nothing but the microcomputer. Microcomputer. But micro it is. It is micro computer. Compressed computation. So microcontroller is also known as embedded controller. It can be 8-bit, 4-bit, 16-bit, 64-bit, 28, 128. Microcontroller is compressed microcomputer. It is the compressed microcomputer. Again the same, which we have discussed in just previous lecture for some 5 minutes. In the open source software hardware lecture number 8, at the end of the lecture we have discussed this, how the compressed microcomputer is there. It is manufactured for controlling the functions. The microcomputer controller comprises the components memory, peripherals, and processor. Okay. So we have discussed this. We have discussed the different types of the microcontroller. Microcontroller types may be central processor unit CPU microcontroller, or the CPU of the microcontroller is a brain. Microcontroller is having CPU. CPU is a brain. CPU is used to fetch data, decode data, complete the task. So CPU connects all the components together. CPU fetches the data and programmable memory and decode it. The microcontroller consists of memory also. In microcontroller, memory chip works as a same as the microprocessor in case of microprocessor. So memory chip stores all the programs and data. Microcontrollers are built with certain amount of ROM, RAM, EEPROM, flash memory, storage of the program source code. These details of history, a story of the uh, ROMs we have discussed in one previous lecture, isn't it? Maybe 6th or 7th lecture. So microcontroller also consists of input output ports, IO ports, and these are basically microcontroller consists of input output ports or IO ports, and these are basically employed to interface or drive different appliances such as printers, LCDs, LEDs, etc. Okay. So serial ports, these ports are serial interfaces with microcontroller and various other peripherals similar to parallel, like parallel. Okay. Just like the parallel port, there is a serial port. Microcontroller also consists of timers or also as a counters, and it can count the events, or it can store the time, and it can provide the time delay for any application or any action. So what are the applications where timers are there? So pulse generation, clock functions, frequency measuring, modulation, and making oscillations. On off oscillations, square wave. Microcontroller consists of analog to digital converter, ADC. ADC is employed to convert analog signal to digital signal. Why? Because microcontroller understands digital, and external circuit may give analog, like some sensors, analog signal is generated. Then to communicate, to convey, to give the information of the external circuit to the microcontroller, we have to convert the external circuit analog voltage into digital voltage. So there must be requirement of the analog to digital converter. So input signal need to be analog for the ADC. Digital signal production can be employed for the different digital applications such as measurement gadgets. Similar to ADC, there must be DAC, digital to analog converter. Same reason, because microcontroller knows only digital, and if you want to interact with the external circuits, and external circuit understand analog, so microcontroller communicates, gives some message in the digital form, and that must be converted into analog, so that the external circuit can understand that message in terms of signal amplitude. So digital to analog converter, DAC is also required, which is the opposite function of ADC. ADC is generally employed to supervise the analog applications like DC motors. So this is a interrupt controller. Microcontroller is employed for giving the delay control for working program, delayed control for working program, and interrupt can be internal or external. Interrupt is interrupting the main program and executing the sub program or interrupt routine. Microcontroller also consists of special function blocks of some special microcontrollers manufactured for special appliances like space system, robots, etc. And special block has additional ports so as to carry out some special operations. Microcontroller types are there based on memory, based on architecture, based on bit, based on instruction sets. 8-bit, 16-bit, 32-bit microcontrollers are there based on memory, external memory microcontroller, and what is other? Embedded memory microcontroller. External memory microcontroller and not internal memory microcontroller, isn't it? External memory microcontroller, and second type is embedded memory microcontroller. Okay. External memory microcontroller, the embedded structure is built with microcontroller which does not comprise of functioning blocks existing on the chip, which is named as external memory. So, memory and other functional blocks are external to the microcontroller. So, it is external memory, and memory and other functional blocks are internal on the same chip. It is called embedded memory microcontroller. Examples: 8031 external memory microcontroller, it is requiring the 64K external memory to be interfaced, and 8051 is internal memory. There is a internal memory on the same chip. Instruction set based types. The types are also there based on instruction set. A complex instruction set computer CISC and reduced instruction set computer RISC. Complex instruction set allows the user to apply one instruction as alternative to many simple instructions. Many simple instructions are taken and one complex instruction is made. So it is complex instruction set computer. And simple different instructions are there. So that is called reduced instruction set. Reduce the operation time by shortening the clock cycle per instruction. So memory architecture type controller types are there. Harvard memory architecture microcontroller is also there, and Princeton memory architecture or von Neumann architecture of microcontroller is also there. Memory interfaces are same for the program memory and data memory. And in case of Harvard, memory interfaces are different for program and data memory. That means data memory is different, program memory is different, interfaces are different. So Harvard memory architecture microcontroller can at that same time interface the interact for the or fetch the data or fetch the program. So program and data can be simultaneously accessed by the microcontroller. And in case of Princeton memory architecture, because the data and program are on same memory and one interface commonly is used, then either it can access the program or it can access the data. So same program and data memory is there in case of Princeton or von Neumann. Now then we have seen the 8051 family. 8051 family is having the huge, it is very famous and it is used by many applications or many users, and it is groundbreaking. After this particular microcontroller, lot of fast microcontrollers are introduced and systems are introduced. It was invented by Intel. So this family has the 8051 and 8031. 8051 is the higher version and 8031 is a lower version. 8051 is having all the same facilities and functional blocks, and additionally 3 timers and 256 bytes of RAM is there in the 8052 as compared to 8051. Similarly 8031 as compared to 8051, 8031 is having microcontroller that is ROM-less. There is not ROM inside. And the features of traditional 8051. If you traditionally 8051 is considered, there is no RAM in the 8031 as compared to 8051. And for execution, external ROM of 64 kilobyte can be added to the chip. Okay. So this is the difference. This is the difference of same family microcontrollers. So 8051 microcontroller architecture is there. 8051 architecture is having 8-bit microcontroller, 14-pin dual inline package is there. We have seen the last time. The package means the IC which is having the pins on both the sides. Dual inline. Okay, 20 pins on this side, 20 pins on this side. It will become 40-pin package. Then 4 KB of ROM is there on chip programmable space, and 128 byte of the RAM space is there in which is inbuilt. Then 64 KB external memory can also be interfaced with the microcontroller. Just like the 8031 requires the external memory compulsorily, but 8051 can be connected. It is not compulsory because there is internal RAM, ROM in the 8051. If they are sufficient, external memory is not required. But external memory can be interfaced with 8051. So these pins can be addressable pins. Then four parallel 8-bit ports are there, programmable as well as addressable. Four parallel 8-bit ports are there. Four parallel 8-bit ports. 8-bit ports are there. How many? Four. And they are parallel. 12 megahertz on chip crystal oscillator is there. 12 megahertz on chip crystal oscillator. Okay. Then serial input output port having two pins, two timers of 16 bit. These timers can be employed as a timer for internal function as well as counter. 5 interrupts are there. Serial port interrupt, timer interrupt 1, timer interrupt 0, external interrupt 0, external interrupt 1. All these are there. The programming modes are either GPR, general purpose registers, or SFR, special function registers, and SPR, that is special purpose registers. So these programming modes are there. Then we have seen the details of peak controller, peripheral interface controller. Peak is peripheral interface controller. Peripheral interface controller peak provided by Microchip. Microchip is a company or technology to categorize its solitary or single chip microcontroller. It is solitary or single chip microcontroller. Single chip microcontroller peak control. These are extremely successful in 8-bit microcontroller. Extremely successful in 8-bit, very popular, extremely popular in 8-bit microcontroller. So 8051 is also popular and PEEK are also popular in 8-bit microcontroller. The foremost cause behind is microchip technology is constantly upgrading the appliance architecture and included much required peripherals to the microcontroller. It included much required peripheral to the microcontroller. Whatever the required hardware is required or block is required, peripheral is required, that is introduced. So it is continuously upgrading. The peak microcontrollers are very popular with the hobbyists, the industrialists, and it is only cause of wide availability, low cost, large user base, and serial programming capability. It is a serial programming capability. So, peripheral interface controller, peak controller is having these uh, causes for becoming popular among the hobbyists and industrialists and projects and students, etc. And it is very successful, extremely successful because it is extremely popular in use. So this is about the peripheral interface controller, peak controller. This is about the peak controller. Peak is peripheral interface controller. This is one type of the microcontroller. This is also the microcontroller. Just like the 8051 microcontroller, 8031 microcontroller, 8052 microcontroller, Intel microcontrollers. Similar to that, one other type of the other microcontroller is also there, that is called as peak microcontroller. So there are different, again, numbers of peak controller and different controllers are there. They will have different capacities, specifications. So this is about the peak microcontroller. What is there in the PEEK microcontroller architecture? The architecture of 8-bit PEEK microcontroller can be categorized. 8-bit PEEK microcontroller can be categorized, its architecture, as baseline architecture. Baseline architecture. In the baseline architecture, the PEEK microcontrollers of suppose PEEK 10F family is included. PEEK 10F family microcontroller. Just like 8051 family microcontrollers are there, 8051 family microcontrollers. Which microcontrollers are there in the 8051 family? 8052, 8031 and 8051. These are the 8051 family microcontrollers. Similarly, the PEEK microcontrollers, the PEEK 10F family is there. Other than that, the fraction of PEEK 12, PEEK 16 families are also included. In baseline architecture, the family of PEEK 10F is there, PEEK 12 and PEEK 16 families are also included. These gadgets make use of 12-bit program. These gadgets make use of 12-bit program. Word architecture with 6 to 28 pin packages alternatives. The 12-bit program word architecture with 6 to 28 pin architecture is there. 6 pin architecture is there up to 28 pin architecture. Variety of the architectures are there. Variety of the architectures are there. Alternatives are there. Briefly defined attribute set of baseline architecture. Okay. Baseline architecture in PEEK. Very briefly defined attribute set. What are the attribute set that in case of PEEK microcontroller so that it can be said as baseline architecture? If for baseline architecture, what are the attributes in case of PEEK microcontroller? The baseline architecture allows the most lucrative, profitable product solution. Most profitable product solution. The architecture is perfect for battery enabled gadgets. This architecture is perfect for battery enabled gadgets. The PEEK 10 F200 series is another reasonably priced 8-bit flash microcontroller with 6-pin package. So this is having 6-pin package. PEEK 10 F200 series is 6-pin package and it is reasonably priced 8-bit flash microcontroller. 8-bit flash microcontroller. So PEEK microcontroller architecture. The architecture of 8-bit PEEK microcontroller can be categorized as mid-range architecture. One is range architecture or baseline architecture. Baseline architecture. Second is mid-range architecture. Mid-range architecture. In this, middle number of PEEK 12 and PEEK 16 families are added that attribute 14-bit program word architecture. In case of baseline, it is 12-bit program word architecture. 12-bit program word architecture. In case of mid-range architecture, it is 14-bit program word architecture. It is 14-bit program word architecture. The mid-range PEEK 16 gadget offer a broad variety of package alternatives from 8-bit to 64 packages. 8 to 64 packages with low to high levels of peripheral incorporation. With low to high levels of peripheral incorporation. Low to high level of peripheral incorporation or interfacing is there at low level or high level. This PEEK 16 appliance attributes a variety of analog, digital and serial peripherals. PEEK appliance 16 appliance attributes Variety of analog and digital serial peripherals like SPI, UART, I2C, USB. Okay. So these peripherals or protocols or communication uh, ports can be interfaced. Similarly, LCD AD converters can also be connected or interfaced. This PIC 16 appliance attribute a variety of analog and digital serial peripherals. Variety of analog and digital serial peripherals. SPI, UART, I2C, USB, LCD, AD converters. The mid-range peak 16 microcontrollers have suspended controlling ability with an 8 level hardware load. Okay, mid-range peak 16 microcontrollers have suspended the controlling ability with 8 level hardware loads. So peak microcontroller architecture, the architecture of 8-bit peak microcontroller can be categorized as also high performance architecture. One is baseline architecture, second is mid-range architecture, okay, and one more is high performance architecture. The high performance architecture included the Peak 18 family of appliances. High performance architecture included the Peak 18 family. Baseline included Peak 10F, Peak 12, Peak 16 also a 12-bit program word architecture. Mid-range Peak 12 or Peak 16. Okay, Peak 12 or Peak 16. 14-bit program word architecture. And high performance Peak 18. High performance peak 18. So peak 10, peak 12, peak 16 is also there. Peak 10, then mid range peak 12 and peak 16, and in high performance peak 18, peak 12, peak 16, and here peak 18. The high performance architecture included the peak 18 family of appliances. The microcontroller make use of 16-bit program. Here it is 16-bit, 12, 14, and 16-bit program word architecture. 16-bit program or architecture. Here it is 16-bit program or architecture along with 18 to 100 pin package alternative. 6 pin to 24. Here it is 18 to 100 pin package alternative. The peak 18 appliances are high performance microcontrollers. Peak 18 appliances are high performance microcontrollers. Okay. With incorporated analog to digital converters. With internally incorporated analog to digital converters. All peak 18 microcontrollers integrate a highly developed RISC architecture, reduced instruction set architecture. All peak 18 microcontrollers integrate a highly developed RISC architecture that supports flash appliances. The peak 18 has improved foundation attributes 32 level deep load and several internal and external interrupts. This is about peak microcontroller architecture, baseline architecture, mid-range architecture, and high performance architecture. Okay. So these are the different peak microcontroller architecture. 8-bit is there, peak microcontroller. This is base architecture. Peak 10F. Then mid-range architecture, peak 12 and peak 16. Again, it is 8-bit. Okay. This is 8-bit. This is 8-bit. And high performance architecture 8-bit peak microcontroller is 16-bit program word architecture is there. Okay. High performance architecture. Now what is the next microcontroller? The next microcontroller is AVR. AVR microcontroller. AVR microcontroller architecture was developed by Alf Egil Bogan and Vigard Uller. Alf Egil Bogan and Vigard Uller. AVR microcontroller architecture was developed. The name AVR is derived from the names of the architecture developers. AVR, AVR, Alif, Alf, A, V, vegan, AVR, architecture. It is also called as Advanced Virtual RISC, AVR, microcontroller. Advanced Virtual RISC type of the reduced instruction set RISC type of the microcontroller. It is customized Harvard architecture 8-bit RISC solitary chip microcontroller. Customized Harvard architecture. What is Harvard? Both the memories are separate, program memory and data memory. It was invented in year 1966 by Atmel. It has Harvard architecture that signifies program and data are assembled different spaces and used simultaneously. Program and data are assembled in different spaces. Okay, that's why they can be used simultaneously. Advanced Virtual RISC AVR microcontroller, it was one of the foremost microcontroller families to employ on-chip flash memory basically for storing the program. It was one of the foremost microcontroller AVR. It has a flash memory as a contrasting to one-time programmable EEPROM, ROM as compared to one-time programmable EEPROM, ROM. It is having flash memory. Flash memory can be very fastly written, erased, written as well as erased. Utilized by other microcontrollers at the same time. The flash memory is contrasting to the these EEPROM and utilized by other microcontrollers at the same time. Flash memory is a non-volatile, non-charging or power down. Okay. So even though the power down is there, the data remains intact. It is non-volatile programmable memory. Non-volatile programmable memory. It is having flash memory. So advanced virtual RISC, that is AVR microcontroller, is having flash memory. AVR microcontroller architecture, the SRAM, flash and EEPROM are interconnected on single chip. So in case of AVR microcontroller architecture, the SRAM, the flash and EEPROM, different memories are there, all are interconnected, incorporated in single chip. All are incorporated in single chip. In single chip, what are incorporated? Three types of the memory. What are the three types of the memory? What are the three types of the memory? SRAM, flash, EEPROM. SRAM, flash, EEPROM. So SRAM is RAM memory, random access memory. Flash memory, very fastly operatable memory for writing and reading. And electrically erasable programmable random access memory. So ROM is, flash is both, flash and ROM are non-volatile, whereas RAM is a volatile. Use of these memories eliminate the requirement of any other external memory in maximum devices. Use of these memories eliminates the requirement of any other external memory in maximum devices. For maximum number of devices, for almost all devices, large number of devices, use of external memory is not required. Use of external memory is not required because the SRAM, the flash, the EEPROM, they are sufficient for writing the program code, writing the data, program code and data, both. Not required external memory. So it is sufficient. SRAM, then flash, then EEPROM. Several appliances. SRAM is for while execution it is used. It is volatile, but for storing the memory there, this program and data, the flash and EEPROM is used. For several appliances comprise of parallel external bus alternatives so as to add extra data memory gadgets in case of several applications comprising of parallel external bus alternative. Parallel external bus alternative is there. So several applications can be added, can add extra data memory gadgets. Can add extra data memory gadgets. Approximately all appliances except a tiny AVR chip. Tiny AVR chips are there. Comprise the serial interface which is used to link large serial flash and EEPROM chip. Approximately all appliances, all the ITML microcontrollers except the tiny AVR. Tiny AVR, if you separately taken, consider, remaining all, most of the microcontroller chip comprises serial interface which is used to link large serial flash and EEPROM chips. So this is about the ATML chip. So ATML chips are used in our Arduino board also. Arduino board also. In case of open source software hardware, we have seen the Arduino boards, isn't it? These Arduino boards, ATML 328 IC is used. So this is about the ATML. Okay. This is about the. What about the next? ARM microcontroller architecture. So we are seeing the different type of the microcontroller architectures, that is the Intel based 8051, then PEAK, then ATML, then ARM microcontroller architecture. ARM is the name of the company. ARM is the name of the company that designs the microprocessor architecture. That designs the microprocessor architecture. ARM is a company that designs microprocessor architecture. It is also engaged in licensing them to the producers who fabricate genuine chips. So some other companies, some other fabricators or producers, some other producers of the chip are producing genuine chips, then it can license also to them to produce the chips. ARM can license in producing the chips. So ARM is a 32-bit genuine RISC architecture. ARM is 32-bit genuine RISC architecture. It is 32-bit genuine RISC architecture. 32-bit architecture. ARM is 32-bit architecture. ARM microcontroller architecture. In case of ARM microcontroller architecture, it was initially developed in year 1980 by Arcon Computers Limited. Okay. ARM microcontroller architecture. If you consider it, it was initially developed in the year 1981 by Arcon Computers Limited. Initially, ARM-based microprocessors does not have onboard flash memory. Initially, whenever the ARM-based microcontrollers or microprocessors were introduced, while there, they are not having the onboard flash memory. They are not having onboard flash, does not have onboard flash memory. Initially, does not have onboard flash memory. Okay. Afterwards, it have adapted, it have introduced afterwards. What introduced? Onboard flash memory. The ARM is designed for microcontroller devices, simple to train and use. ARM can be designed for microcontroller devices, same to train and use. And powerful, ARM is a powerful enough for most challenging embedded devices. ARM is designed for microcontroller devices. ARM is designed for microcontroller devices. ARM is designed simple to train and use. ARM is designed powerful enough for most challenging embedded system devices. Embedded devices. ARM microcontroller architecture. The ARM architecture is 32-bit RISC operator. 32-bit RISC operator. Developed by ARM Limited. The ARM architecture is 32-bit RISC processor developed by ARM Limited. Owing to its power saving attribute, it is having the power saving attribute. ARM central processing units are predominant. ARM CPUs are predominant in mobile electronics markets. ARM are used in mobile electronics or mobile handsets as a mobile embedded system, mobile phone embedded system. So ARM central processing units are predominant in case of mobile electronic market, where less power expenditure is viral design aim. So who, whatever the, whosoever the mobile type of the architectures are there, maybe mobile phone, maybe other some mobile handy and mobile system, okay, which can be mobile system, which can be moved here and there. So in those cases, mobile cases, ARM processors are very popular, or they are used because of the complex working styles or complex working capabilities, and predominant in mobile electronic because less power expenditure is the vital design aim, because it is the mobile devices. That means mobile phone is one of the mobile devices. Maybe other type of the mobile or portable devices are there. Not only the mobile phone, other devices which are mobile, which can be moved, which can be, or which are portable, which can be handled, handy. Those mobile type of the devices architecture, it is 32-bit 6 RISC processor, RAM, ARM Limited, owing to its power saving attributes, it saves the power, where less power expenditure is the design aim. Whenever there is a design aim of less power expenditure in viral design aim. So it is popular in case of mobile device because less power expenditure is there. ARM microcontroller architecture comprises of following underneath these elements. Following underneath these elements. ARM architecture comprises of underneath these elements. ARM architecture contains of the following RISC elements. The maximum single cycle functioning. Maximum single cycle functioning. Constant 16 to into 32-bit register file. Constant. Constant means what? non-volatile, not changing. Constant means not changing. Constant is not changing, means constant. Non-volatile, non-volatile. Which is the memory which is volatile? Which is the memory type which is a volatile? The memory type which is a volatile is RAM memory. RAM memory. Random access memory. Okay, random access memory, which is the RAM memory, isn't it? Random access memory, which is volatile, and that is not constant. So constant 3216 by 32 bit register file. It is a register file. Load or store architecture. It can load or store the information and data. Preset instruction width. It is having the instruction width. It is a preset instruction width. How much it is? Preset instruction width of 32 bits. 32 bits. Instruction width preset. It is already preset. How much it is? 32 bits. So as to simplify. Pipelining and decoding at minimize the code density. Pipelining is a concept of processors, computers. Present instruction width is how much? Present in instruction width is 32 bit. In this case, instruction width is 32 bit. So as to simplify the pipeline and decoding. Pipeline is there one type of the process, and decoding of the program. In case of decoding of the program. In case of execution, whenever there is a execution of the program, whenever there is a run of the program, in those cases, what is happening in the microcontroller, microprocessor? Microprocessor or microcontroller is fetching the data, isn't it? Fetching the data. Microcontroller or microprocessor is fetching the instruction also. Fetching the instruction, fetching the data. What is the use done with fetch the data? How it is utilized, the fetch data? It is utilizing the fetch the data for decoding. What do you mean by decoding? There is a meaning for each and every instruction. Each and every instruction is having some meaning. Each and every instruction is saying something. It is asking something to do to the microcontroller. Suppose move instruction is there. What it is saying? It is saying that one register content is to be moved to other register content. Unconditional jumps, conditional jumps are there. What it is telling? It is telling to jump from one address to the other address. And whatever it is telling is understood by decoding the instruction. Decoding the instruction. Okay. So that is the decoding of the instruction. What do you mean by decoding of the instruction? Instruction is fetched and it is verified or checked what that instruction is saying. That what that instruction is saying or what is the meaning of the instruction, that understanding of the processor is called decoding by the processor. It understands the meaning of the instruction by decoding the instruction. If the instruction is decoded, then the meaning of the instruction can be understood. So that is called decoding. That is called decoding of the instruction. So ARM architecture comprises of the underneath RISC elements. Maximum cycle functioning is there. Maximum single cycle functioning, because RISC is a single cycle function. Okay. Constant 16 by 32 bit register file is there. 16 by 32 bit constant register file. That means the volatility is not there. Okay. It is a constant 16 by 32 bit register. It is a load store architecture. A preset instruction width of 32 bit is there so as to simplify the pipelining and decoding at minimum code density. Minimum code density. For misaligned memory access, there is no support. In this case, misaligned memory access, there is no support. If the memory access is misaligned, to gather that it has no support. Now we have seen the decoding in case of computer or microcontroller, microprocessor decoding. In this decoding, to optimize the decoding, to enhance the performance of the decoding function, pipelining, parallel processing is introduced. Pipelining or parallel processing is introduced. What do you mean by parallel processing? What do you mean by pipelining? In simple words, whenever the computer, microcomputer, microprocessor is having the facility of parallel processing or pipelining, in that what this processor, microprocessor, computer, microcomputer is doing is it is executing some instruction. It is understanding the meaning of the instruction and it is working on that instruction to obey that instruction, to follow the instruction, to make the result, generate the result according to the instruction, etc. So one instruction is decoded, then next instruction is fetched, and that is again decoded. In fetching and in decoding, some time is required. In fetching and in decoding, some time is required. After fetching, it is stored somewhere in the faster memory, maybe RAM or something, RAM. So in fetching and putting into the faster memory, it takes some time, and then the decoding some time. So that introduces the delay. Okay, it takes some time, na? Fetch the memory, decode it, in fetching and storing in the fastly acting memory, and then it is decoded. So it takes some time. Now how to reduce that time? How to reduce the time is attempted, is used as in by using the pipelining technique. By using the pipelining technique, parallel processing technique. Okay. It is by doing the parallel processing. What do you mean by parallel processing? What do you mean by pipelining? So there are instructions in the pipelining. After this instruction, next instruction in the pipeline is executed. Then again, next instruction in the pipeline is executed, isn't it? So there is a simple thing that one after this particular instruction, you have to fetch next 4, 5 instructions, next 6 instructions to complete the next tasks. But sometimes there are jumps. Sometimes there are jumps. So from this instruction, it is jumped directly to the somewhere else. Now that jump is based on some decision making parameter. If that parameter becomes true, jump is taken on this side. If parameter is false, jump is taken on other side. Then in case of parallel processing, the for making the performance faster, execution time lesser, in case of pipelining, one code, one instruction is being executed at the same time. Parallelly, many instructions are next instructions are fetched and stored in serial pipeline. Now, if there is no issue, no problem with execution of serial codes or serial mnemonics or serial instructions, then it can be very fast execution. But if there is a jump, then we have to erase or flush all the 4, 5, 6 instruction fetched, and we have to fetch new instruction according to the jump decision. Okay, so this is how the pipeline works. What is pipeline working as parallel processing? It is for making the processing faster. How it is working? How to make it faster? How the processing performance is made faster? By one decoding instruction is fetched and it is executed. During that time, many more 6, 5, 7, 8, 9 instructions are fetched. Next instruction and kept in the faster memory in the buffer, and then immediately next instructions will be executed. Obviously, next instruction has to be executed. But in case some flushing is required, all the fetched instructions are not required to execute, and some other instruction is needed to be executed. In that, the fetched instructions need to be erased and new instruction is to be. So that will introduce some time delay. Okay. To reduce the time delay, we are fetching early the instruction and keeping in the buffer so as to execute faster after one instruction all the next instruction. This is called pipelining, or it is called parallel processing. Okay. So present instruction width is 32 bit so as to simplify pipelining and decoding at minimize the code density. The misaligned memory access, there is no support. So this is about the ARM architecture. I think 1 hour is completed. We will continue the same ARM architecture, remaining portion in the next lecture of embedded systems, and we'll stop here. This embedded system lecture. I will upload these lectures, both lectures, on the YouTube. I think you are only some of the students who are attending. Uh, 8, 9, 10 students were there. Now there are 8 attending. So if you have any query, you can again recheck on the YouTube videos. Same lecture videos I am uploading, and then you can use the same videos for writing the notes also, but again watching this, or you can note down the points while discussed in the lectures. Okay, we'll stop here, and we'll have the tomorrow lecture, maybe tomorrow lectures at 11 or 11:30. Okay, regular lectures, because yesterday and today there were holidays. We have rescheduled it for some other time, but I think in early morning or in the morning session 11:30 it is better to have the lectures. If you have any query or any suggestions, you feel free to suggest any time regarding or any speed of the lecture regarding or understanding regarding issues. Okay, if you want to suggest it, if you want to say anything, you can always welcome. Okay, so now we'll stop. Thank you.